The Calculus Behind the Jump Shot by Malachi Loatman and Briar Cagle. Today we are diving into the fascinating world of calculus and its application in shooting a basketball. We will explore how mathematical concepts help us understand the trajectory of a basketball and the optimal conditions for making a successful shot. Exploring the application of calculus in basketball shooting, understanding the trajectory and optimal conditions for successful shots, the way the basketball follows a parabolic trajectory, analyzed using calculus, derivatives, and integrals. That's all we will be talking about today. Some key concepts. The trajectory. The path that the ball follows can be modeled by the quadratic equation y equals ax squared plus bx plus c. Y equals the height of the ball, x is the horizontal distance, and A, B, and C are constants based on the initial speed and angle. The Calculus Behind the Jump Shot by Malachi Loatman and Briar Cagle. Today, we're diving into the fascinating world of calculus and its application in shooting a basketball. We will explore how mathematical concepts help us understand the trajectory of basketball and the optimal conditions for making a successful shot. When the basketball is shot, it follows a parabolic trajectory, and this curve can be analyzed using calculus specifically through the concepts of derivatives and integrals. Some key concepts are the fact that the trajectory is modeled by a quadratic equation, which is y equals ax squared plus bx plus c. Y is the height of the ball, x being the horizontal distance. A, B, and C are the constants that depend on the initial speed and angle of the shot. The graph above shows the trajectory of a basketball shot with a labeled parabola. To find the maximum height and distance of a shot, we can use calculus. Finding the vertex is the first step. The vertex of the parabola, which represents the maximum height, can be found using the formula x equals negative b divided by 2a. Calculating the height next, plugging in the x value back into the original equation gives us the maximum height. The equation now is y max equals a times negative b divided by 2a squared plus b times negative b divided by 2a squared plus c. In the following graph, a step-by-step is shown of how to find the vertex of a parabola. Several factors can influence the outcome of a jump shot, including initial velocity, the speed at which the ball is released, angle of release. As mentioned, the angle significantly affects the trajectory, height of release. Shooting from a higher point can change the dynamics of the shot. As you see in these illustrations, when you shoot at different angles, you have a higher chance of hitting just the rim, a swoosh, maybe bouncing off the back of the rim, all types of ways the basketball can go in. To be used in the real world, understanding these principles can help players improve their shooting technique. Coaches often use video analysis software to study players' shooting mechanics, applying calculus to their performance. As you see this demonstration of a very famous coach, or maybe not very famous, but he's quite known for analyzing skills very deeply. Some citable sources are Harris R. 2020, The Physics of Basketball, Analyzing the Arc Journal of Sports Science, and Smith J. 2018, Mathematics in Sports, The Application of Calculus, Mathematics Today. In summary, the interplay of calculus and basketball shooting reveals how mathematical principles can enhance athletic performance. By understanding the trajectory, players can refine their techniques and increase their chances of success on the court. And who wouldn't want to boost on the court?
Our project is on the calculus behind shooting a basketball, a great way to explore the fascinating intersection of mathematics and sports. The topic focuses on how calculus can be applied to analyze the trajectory of a basketball and provide insights into optimal shooting techniques. The motivation behind this project stems from a question of the best distance to shoot from a basketball from the net. This application of calculus is exciting because it demonstrates the relevance in mathematics in everyday life and showcases how math can improve athletic performance. To solve the example problems presented in the project, we utilized various mathematical techniques primarily focused on calculus. The key materials include textbooks on calculus, online educational resources, and simulation software to visualize the trajectory of a basketball. Techniques employed include quadratic modeling using the quadratic equation, vertex calculation, determining the maximum height of the shot using the vertex formula, graphing, creating visual representations of the trajectory to analyze different shooting angles and heights. I double-checked my calculations by verifying the results against known data and graphing tools to visualize the outcomes. The results of the analysis revealed the optimal angle for shooting a basketball is approximately 45 degrees, which maximizes both height and distance. Visuals created during the project, such as graphs on the trajectory and diagrams on different angles, effectively communicate these findings. This research motivates further studies that could be done to calculate the impact of additional variables, such as air-resistant spin and others. These insights could lead to improved training techniques for athletes and a deeper understanding of the physics involved in sports. The primary data sources for this project include scholarly articles and sports science journals that discuss the physics of a basketball and the mathematical modeling in sports. Notable works such as The Physics of a Basketball, Analyzing the Arc by Harris, and Mathematics in Sports, The Application of Calculus by Smith provide a foundational knowledge on the topic. The problem with our statement is that there are other factors such as angle of release, initial velocity, height, and angle, other than just distance from the net. During the research process, we made adjustments to the original equations to better fit the context of basketball shooting, to ensure mathematical modeling stays accurate and represents real-world scenarios. This project has significantly motivated me to engage more deeply with the material and math of my calculus class. It has illustrated the practical applications of mathematical concepts, reinforcing the idea that calculus is not just an abstract subject, but a powerful tool for solving real-world applications of problems. The ability to apply calculus to optimize performance in athletics is a valuable skill that can open doors to various opportunities in the sports industry and beyond. In conclusion, the project on calculus behind shooting a basketball has provided valuable insights into the practical applications of mathematics. By analyzing the trajectory of basketball, I've gained deep appreciation for the role of calculus in sports.